Question number 2. A roller coaster trolley begins its journey 5.25 meters above the ground as the motor tows it to the top of the first hill. It gains 4.20 times 10 to the 5 joules of gravitational potential energy. If the mass of the trolley and its passengers is 875 kilograms, how far is the top of the hill above the ground?
Okay.
So we know that the initial height is given as 5.25 meters. So our height equals 0 down here. When the car is at this point, the height is 5.25 meters. Now we know as it goes up to the top, it's going to gain 4.20 times 10 to the power of 5 joules. So the change in energy is 4.20 times 10 to the power of 5 joules until it gets up to the top here. So to figure out the height at this point, we need to figure out the total amount of energy at the final point. We know we can calculate the energy at the initial, and we know the change in energy. So our change in energy is equal to our final energy minus our initial energy. Now in this case, we're looking for the final energy. So that will be our initial energy plus the change in energy. So our initial energy is at this point. So that we have mgh initial plus our change in energy. So that's going to give us the mass, 875 kilograms, times 9.81 times the height, 5.25, plus our change in energy, 4.20 times 10 to the power of 5 joules. So put that into our calculator. So we have 875 times 9.81 times 5.25 meters plus 4.2 times 10 to the power of 5 gives us 46506.6875 joules. So now that we have that, that is the energy at the top. However, we're looking for the height. So our energy final will actually be gravitational energy, which we can replace with mgh, where this is the final height that we're looking for. So to calculate our final height, it will be our energy here, 465,064, etc., divided by mass times gravity. So that's 875 times 9.81. So we take our answer, divide it by 875, divided by 9.81. Again, remember, if you want to multiply, you have to put it in brackets because you have to force the multiplication before it does the division. So I put that in my calculator, I get 54.179666361 meters. With significant digits, we're going to round it off to 54.2 meters. And we take a look in our textbook, 54.2 meters is what we're looking for.